Hey, this is Joshua Ruderman. Let's do a couple more problems, but this time we're gonna kind of take it up a notch, okay? So we're gonna continue doing the factoring, but I guess this could be considered a part 2 because now in all of these trinomials, we don't just have numbers in the back, but we also have numbers in the front. So there's a couple different ways to do this. I've seen people show me like the X method where you fill in these boxes and stuff, and it works up until a certain point, but then what I noticed was that as the numbers up here get bigger, it gets a little bit trickier to do the factoring using the X method. If you aren't familiar with that method, don't worry about it. Maybe I'll teach it in a different lesson. But for now, let's just jam through these guys, okay? Now, this first guy here, let me write it out here. 6x squared minus 19x plus 15. Again, I'm assuming you've watched my other videos, so you understand that we need to factor the back and then take care of the front as well. 15 is 15 and 1, 5 and 3, and I guess that's it. But just like we factored the back, we need to factor the front value as well. So 6 and 1, 3 and 2, I guess that's it, okay? And now it really just becomes like a guessing game almost. I mean, it's an educated guess because as you get better at this, you'll start to reason with like what it is you need to do. And again, this is why you need to know those math facts because you're gonna be struggling with a calculator when you could just be knowing this stuff in your head. I need two numbers that when multiplied make 6, but then, oh, you know, I got a lot going on in the middle. And so I really do just kind of need to guess. I mean, 15 is kind of a big number. I don't know if that number is going to work. I don't know if 15 and 1 is going to get me a 19 using these other numbers as well. So I'm going to go with these two first and then see what I get. And then, I don't know, I'll just pick the first set as well. And again, like I might have guessed wrong, I might have guessed right, but just understand that sometimes it really is just a guessing game of fitting in all the pieces and seeing what works. So let me fill these in. You know, they're both going to be x. Oops. 3x and 2x. And they're minus in the middle, plus in the back. So that tells me that this is going to be a minus minus. Again, that's nothing new. If you watch the other video, you should know why those are both minuses. And now I need to fill in that next value. Well, I need to get to 19. So let's see here. I'm gonna do 5 and 3, and here's why. First, okay, well we know that's gonna work. Now let's do outside is gonna give me a negative 9x, and then negative 5 times 2x is gonna give me a negative 10x. So it looks tricky, right? Because you got all these numbers and it's like, how do I know what one's gonna actually work? Sometimes you just gotta try them all. And it's not pretty. And as this number gets to be like, you know, even 24, okay, with 24, you got 24 and 1, 8 times 3, 6 times 4, 2 times 12. And then you might have to do 2 times 12 or I'm sorry, 2 times 12 or 2 times 12. Like you might have to reverse them. So it's almost like you have double the work. And then you got the front numbers that are mixing with it as well. So it can get kind of crazy, but it really comes down to knowing what to do with these and then knowing how to set these up through trial and error. All right, so hopefully this starts to make sense, and I'm gonna move on to the next one. Now, this next one has a little bit of a rule that goes with it that I haven't mentioned yet, and so let's talk about that now. Let me write this up real big here. 6x squared minus 2x minus 8, okay? You're factoring these problems, and so if you want to think of it this way, before you start factoring, before you do anything, you got to look at it and say, is there a number that I can pull out of all three of these just to make the whole thing smaller? Because that would be a factor, right? It would be a factor of all three components. And what I mean by that is this. Is there a number that I can pull out of this, this, and this equally? Yes, there is. And again, this is where those math facts really do play a part. We can pull a 2 out of all three parts of this. Now, you could factor this. Sometimes it works. Like you don't notice that you can pull out a 2 and you factor this. And what ends up happening is your answers are, they're not wrong. They're just like not completely factored. Okay, it's kind of like simplifying a fraction. And then it's like, if you only go so far, well, your fraction is an equivalent fraction to the initial one you started with, but you haven't gone all the way down as far as you can. So again, it's not like that's wrong. It's just that it's not what we're looking for out of this type of problem. When I pull out the 2, now I'm going to rewrite it. So 2 times what gets me a 6? 3. X squared just kind of drops down. 2 times what gets me a 2? I'm going to put a 1 there just because it's a nice little placeholder. And then 2 times what makes an 8? A 4. Now I can factor this guy into my 2 parts. And so I have a 3 here. I have a 3 and a 1. And a 4 can be a 4 and a 1 or a 2 and a 2. But I got to make a 1 in the middle. So let me fill in what I know. I know that I have to use a 3 and a 1 because that's all I got. So 3x and x. And remember, it doesn't matter if you put the 3x here or the 3x here. When you FOIL and multiply, you're going to get the same answer. When it comes to the backside, I don't know. I mean, who knows what it's going to end up being. I need to get to a 1. So I'm going to say 4 and 1 just because it's going to be giving me a 3. It's a minus and a plus. So I'm going to say minus 4 plus 1. Okay, and again, this just comes down to experience and doing these for a while. But when I factor this, I'm going to get, right, outside, that's going to get me a 3x. Inside is going to get me a minus 4x. Okay, and I don't want you getting all tripped up on the, well, how did you know which one goes here and here? Again, a lot of it's just trial and error. Learn your factors, learn how to work on these, understand the FOIL method. And the more you understand the FOIL method, I'm hoping that you then are able to apply it to these factoring problems, because you got to remember all the pieces have to match up and come back together exactly the way it was given to you right here. So if I do a 3 times x and get a 3x and a negative 4 times an x, I get this, which then is going to give me that. All right. And so this one had 2 parts. We had to factor out a 2 and then do this last part. So your final answer would look like, let me just erase some of that in the interest of time. The 2 doesn't just disappear. It just kind of sits out there on the outside. And when it comes to working on quadratics and other stuff, these are technically your 3 different answers, okay? You have this guy, and this guy. These are my factors. And so that's why I can't just take this 2 and just cross it out, cancel it, or just leave it. It technically is part of my final answer. When I was asked to factor, okay, I have this factor, and this factor as my final 3 solutions to the expression. Let me move on to this next guy here. Again, I know I'm going kind of fast through these, but if you're keeping up, you're that much better off. If it's still kind of not making sense, maybe watch it again and just see what I'm doing. It's the same pattern as the basic, x squared plus something x plus a number and factoring it. It's just that we have that little extra guy in the front. 2x squared minus 9x minus 35. Oh, big numbers. Okay, well, let's see. I got 7 and 5, 35 and 1. I don't know if I'm going to be using a 35 to get a number 9, especially if the front is just a 2 and a 1. Okay, I'm probably going to be using, well, obviously I'm going to use that. And I'm just going to assume I'm using that because I only have 9 in the middle, right? Like, what am I going to do? 35 times 1 and 2 times 1? Like, it's just not going to work. I create my parentheses for my 2 binomials. I have a negative and a negative. So I'll fill in these guys first. I know I have a 2x and an x because that comes from here. And then I know I have a plus and a minus. And I don't know if the plus goes in the front or the back, right? I mean, I'm just going to throw them in and then FOIL it and see which one works. So let's do minus 7 plus 5, right? I'm just picking these guys. 2x times 5 is going to give me 10x. Negative 7 times x is going to give me a negative 7x. Is this going to give me a negative 9x? No, it's not. Okay, so that didn't work. Let me try plus 7 minus 5. 2 times negative 5 is going to give me a negative 10x, and that's going to give me a positive 7x. That's not going to work, okay, because that's not going to combine to give me a negative 9. So let me switch these two numbers here. Let's switch the 7 and the 5. Let's switch their location. So let's put the 5 here and the 7 here. 2x times negative 7 is negative 14x. 5 times x is positive 5x. And bam, got it. Because a negative 14 plus a 5 is going to give me a negative 9. Or in this case, negative 9x's, right? Combining like terms. So I didn't get lucky on the first shot here, but I was able to pull this thing off by trial and error, just seeing which one works and which one doesn't. And like I said, sometimes you might be here with like factor, no, it doesn't work, it doesn't work, it doesn't work. And sometimes that's just the way it goes. My hope is that you find it quickly so that you aren't just sitting here struggling. But again, ask questions, get in touch with me, let me know. I'll see what I can do to help you out. So we've worked on these three. This one was special just because you had to remember how to factor out the 2. And again, like look at these numbers. In the beginning, they're going to make it pretty obvious, like, hey, you need to divide all of them by 3 or by 2 or by something. And if you notice there's a fraction in all of them, you can pull a fraction out. If this was x to the third, x squared, x, you could pull an x value out of all 3 as well. So rather than pulling out just a 2, you could actually pull out a 2x if there were 3 and 2 and 1, because each value here has a unit of x. So pull them all out. And sometimes they're going to lead you in that direction anyways, because you're going to look at it and say, well, I got an x back here. Like how am I going to FOIL that thing? It's not going to work. And so that's where you got to start thinking about these rules that we're using today. Let me erase this. This next one was a little bit bigger, and it does say solve, so we're going to actually be solving this one all the way through to see what we get. We have 21x squared plus 14x plus 7 equals 6x plus 11. Now, I'm hoping what you start to notice is that we got a lot of stuff that's kind of similar on both sides. And this problem, I can do some stuff to it that's going to make it look a lot like this guy. I can start moving stuff all onto one side so that I can just work with what I got here and then kind of not worry about the other half, right? And when I mean the other half, it's kind of like equals 0, okay? That's okay. It looks kind of weird, but that's all right. Minus 6x from this side. What you do to one side, you got to do to the other. A common mistake that I see is people subtract 6 from this, and then they subtract it from this and this and this. And I'm like, no, just one time, right? You subtracted one time from this side, one time from this side. Remember, the equal sign is kind of like the barrier. And in order to get across it, you got to add or subtract, at least for these parts. So I end up with 21x squared plus, what's that? 14 minus 6 is 8x plus 7 equals 11. Okay, and now I need to get rid of this guy, right? I need to get it down to 0. So it's a positive 11, minus 11, and minus 11. And I get 21x squared plus 8x minus 4. All right. Now I got to do what I've been doing with all of these guys. So I might as well go a little quicker. 21 is 7 and 3 or 21 and 1. I doubt I'll use those because they're just such big numbers. 4 is 4 and 1, 2 and 2. All right. I got a positive in the middle and a negative in the back. So that tells me that I'm probably going to have a plus minus situation just because a positive times a negative is going to give me that negative. I'm going to go with 7 and 3. And remember, it doesn't matter what you put in the front, because when you multiply, it's going to all come together. Let's see here. Well, I could do 4 and 1. Let's see here. Let's try it. Let's just try 4 and 1. I don't know. Let's try 4 and 1. So 7 times -1 is going to give me a -7. That's not going to give me an 8 in the middle. That's going to give me like, that's not going to work. Let's see here. I could do 1 and 4. Now I'm going to get a 28, a -28. Like, there's no way that's going to balance out or give me an 8. Okay, so it looks like 2 and 2 is going to be the answer. And again, I know I'm kind of talking through that part fast, but as you start to do more of these, as you start to learn your factors, you're going to see the same thing that I do, which is that like some numbers just aren't going to come together to make the value in the middle that you really do need. Let's see here. Outside is going to give me a -14. Inside is going to give me a +6. Well, I'm getting my 8, but it's not working out perfectly. So let's see here. That's giving me a -8, and I don't want that. So if that's the case, and you know this is where everything needs to go, well, let's just switch the signs and see what happens. So let me change this one. Oops, almost did the same thing again. Let me switch this to negative and this to plus and see what we get. 7x times 2 is 14x's. -2 times 3x is -6x's. Now I'm rocking, because 14 minus 6 is going to give me 8x's, which is the middle part right here. And so I've solved, okay, and now, oh, this guy is still equal to 0, right? Actually, I might even need to rewrite. Let me erase this top part. We'll just kind of take it from the top, okay? If you didn't, I'm going to leave this stuff just because I know it's good work, and I want to keep it up there for you to see. 7x minus 2 and 3x plus 2 equals 0, okay? Now, according to the zero product property, which is a different video of mine, we need to figure out how to get this guy to become a 0 and this guy to become a 0, because we know that in order when you're multiplying two numbers together, if one of them is a 0, then everything becomes a 0. And the quickest way that I like to do this is just to take this number and put it over this number, and it gives you your answer, okay? We can talk about the math of that as well, all right? So I need something to be here, so something minus 2 is going to give me 0. Well, I need to make this part into a 2. And if you're not good at that, just know that the numbers you need to make your fraction are already in the binomial, okay? So we have 2 over 7, okay? And that's going to be the answer for this side. And what's going to go over here? I need a negative number to make a -2. Well, I have my values right here. So I have a -2/3, and that's going to be my other x value. So x is going to equal that and that in order to get me down to 0. Now, you might say, well, how did you know it was 2 over 7? How did you know it was 2 over 3? Well, let's just do this quick, okay? If I have a 7, right, it's technically 7 times x. So if I have 7 times, I'm going to make it into a fraction, times 2 over 7, which is what I chose, well, what happens? I can either look at it this way and say, okay, well, 7 times 2 is 14. 1 times 7 is 7, which reduces to 2, okay? And then 2 minus 2 is 0. Or you could look at it from here and just say, well, the 7s are going to cancel, which means I'm going to have 2 over 1, which just equals 2, right? You're trying to get this area right here to turn into a 2. And so that's why we had to use a fraction, because the fraction times the whole number is going to get us down to a single unit that we can then subtract the other number from. And so the quick hint is just to remember, well, the units that you need are always right there in the binomial, okay? And then this one had to be negative because I needed this to become a negative 2 so that negative 2 plus 2 became a 0. All right, your goal was to get this guy equal to 0 and this guy equal to 0. And so my final answers would be these two guys right through here. X equals 2/7, comma, negative 2/3. And those would be our two final answers. All right, so hope that made sense. I know we did a lot of math just now, but stick with it because you can do this. I'll see you next time.